Got some advice from an old friend or someone most of us might know. Gav or TVEV. So this is what he wrote me some time ago. So I've been going back to this every time I am stuck or having some doubts on my capabilities. Well, so thanks again, Gav. I should be somewhere in what Middle Europe or somewhere, having a good time. So enjoy yourself. And back to some wiring work. I've just removed the place where used to be the clutch cable is. So remove that. I've put the cable right here. That's the cable, the whole thing. Cable still look brand new, covered it all inside, protected in the car. So that's a good access point and much nearer a point to go through the firewall and back into the car, instead of the usual one that I've used, the route that goes all the way under here, comes out here, pass through the original hole and go through back into the car compartment. That's a bit long, but it worked. This is another option, so which is if it's a clutchless design, so this is a bloody good option for the wirings. And what I've done so far is I've tried the wiring the shunt. So this is how things are progressing. Once I've finished up the shunt, I've also done the part on the voltmeter wiring. So did a quick update on the drawing. So on the shunt, wire colors are red and yellow. The voltmeter is black and yellow. Black on the negative, yellow on the positive. So for guys that would be planning to make a future conversion, well, just like me, never had the idea of how the circuit diagram would look. We just have to follow, but as we follow it, chances would be we might not be getting the same color wires. So as we go, we just have to update, just in case we our tiny brain can't store all the information and process it back when we need it. So we can always refer it back to this piece of updated wiring. Well, hope that makes sense in the future. It is that is how I started my car when I got it back. This looks like more like an octopus than anything. So it's actually a one-off key switch. I've got sort of a replacement, not the same. It's not the same make. I can't find anything like that. So what I did is I just scavenged one from the junkyard. I brought it back, made a sort of tried to understand a little bit on the wiring. So the wiring seems a little bit odd, or not the same. There's basically three conditions which could happen. The accessory condition, the first step, the on condition, and the start condition. I tried to mimic it as close as possible. So what I've done is I've actually changed over all the old sockets. The old sockets actually seems much more robust than the new ones, to be honest. So I've changed that. I don't mind changing that. So change most of them over here. Now I'm left with the power. So the power that this is the common power. So what happened is it came out and have two. So what the heck is this two? Can't find the other one. So what I've decided to do is the similar power that I could have is actually this solid black wire. The solid black wire which will come out here, and I think I'll just drop in a Y just like this. I keep this, chop it off here, join it there. I'll be done with that. So I'll do some stuff indoor for now. So it's all more or less done up. The switch, the wiring is as so all the sockets, and so all the sockets are all back matching to the original wires in the Mazda. So and the weather's good, so we'll go out and see whatever we can do with the time remaining. So if I've done the wiring correctly, if I look into here, the minus section is the primary contact. Sorry about the angle. So if I've done it correct, means if I put in the wire, I put in the power, the negative portion, which is this one, this contactor would fire up straight away, and when I push that port box, activate that port box, the secondary contactor works. That would be the positive side. So this is the positive terminal, and this will work by the activation of the port box. So here goes. That's the primary side, and I'll go ahead and push the port box. So the secondary fire up means the high current will pass through them. So once I release it, so in a safe way, wiring is done. Okay, all that action going on, and this guy seems to have full confidence on the work I'm doing now. Like he seems quite happy and not too concerned about any problem rising up. I've added in the inertial switch. That means in case of collision, what happens is this switch will high impact. This switch will activate and break up the circuit. So now it's not on. So when it's on, the primary contactor goes on, so the system will activate. And just say, for example, in a situation where I don't really want it to happen, but just in case, this would be for safety purpose, the high collision, the inertial switch, when activated, it would just cut off the whole high voltage system. So I think this is wired correctly. So both of them goes off. Okay, so it's a matter of mounting this thing on some place that is sturdy. So that's the whole idea for the tilting aspect of the board. With all the wirings in, I should be able to still tilt it around and still work within the motor compartment and the compressor and such. So there is one more important, now just to show you, that's where all the cables are going through. It would be covered up later, heatsink and such. Since I've already done it, I've just completed it. So an old piece of aluminium, as you can comprehend, or you can actually guess, the grate at the back is actually a cut off piece from the heatsink clearance. So I've got this, quickly made a few holes, drill a few holes down there, tap 2 more holes so that would fit into it. I made an extra one just in case I wanted to tie the cable ties or whatsoever. So I'll fix it down here where there is the unused these are original holes or threaded holes that are on the car. So I've made that to go in here. I'll fix it up. And the connection would be so. Just need to find a right. Can't go wrong with this connection from EVA. No way you could go wrong. So it's all done. So see you guys next week. Okay. Take care.